and research data service at the University of Michigan Library, and I'll be serving as the moderator for today's sessions. Today's presentations are the second in a series of 8 presentations hosted by the Michigan Institute for Data Science, or MIDAS, showcasing the work being done on research reproducibility issues at the University of Michigan. Each of these presentations was submitted as an entry in the MIDAS Reproducibility Challenge, which took place earlier this year. The series will run through the summer and culminate in a day-long summit on issues of reproducibility in research on September 14th, 2020. We're very much hoping that the MIDAS Reproducibility Day will be an in-person and interactive event. Please keep an eye out for more information throughout the summer. In developing the MIDAS Reproducibility Challenge, we sought to highlight the high-quality work on or relating to research reproducibility happening at the University of Michigan. And as in many emerging areas, there are multiple definitions for what constitutes research reproducibility. We adopted the broad definition provided by the National Academy's Committee on Reproducibility and Replicability in Science. They define computational reproducibility as obtaining consistent computational results using same input data, computational steps, methods, codes, and the conditions of analysis. Today we'll hear 2 presentations. Okay, let's go ahead and move on to our second presentation. Our second presentation will be led by Jared Lyle, an archivist at ICPSR. Jared will be joined by Lars Vilhuber, the Executive Director of the Labor Dynamics Institute at Cornell University, Maggie Levenstein, the Director of ICPSR, and Chelsea Goforth, a Data Project Manager at ICPSR. Jared and his co-presenters will be presenting on the developing the American Economic Association's Data and Code Repository at Open ICPSR, and how ICPSR is assisting the AEA in enacting and operationalizing its recently adopted data and code availability policy.
Great,
Jared,
thanks.
go ahead.
Thanks, Jake. I'm actually going to turn it to Maggie Levenstein, Dr. Maggie Levenstein, who's the director at ICPSR, to start the presentation. Maggie.
Thank you, Jared. So I think you're controlling the slides, yes? So yes, so I just want to give a little bit of motivation for the project that we're going to talk about today. ICPSR has for almost 60 years been committed to openness and access to data. And reproducibility is one goal of that access, though obviously the kinds of issues that Jake was talking about are also things that the sort of the identification and not reproduction of errors is another one. In the terms of this particular project, I would say it has actually 2 different origins. One is that the American Economic Association adopted in 2005, so very early on, a data sharing policy, which was, and in doing so, it was really a leader in its field in facilitating reproducibility, trying to address challenges that had been made to the research produced by the AEA, saying that it was impossible for people to reproduce the results that were published in its journals, that it was impossible to sort of see how sensitive they were to changes in specification or changes in the data. And so in 2005, in response to this, it adopted a policy requiring that all empirical articles share the data and a code associated with those articles. And it included, as was a leading and best practice at the time, it included those as sort of supplementary materials on its website. This was no question about it, an enormous advance for social sciences and was really a model at the time. It did not, however, solve all of the problems with reproducibility. So in 2013, quite famously, there was a paper published by Herndon, Ash, and Poland that identified errors in a very prominent and influential work by Reinhardt and Rogoff. And those errors were literally problems in their Excel spreadsheets, but that were only identified later, of course, when the data are made available. In 2016, articles published in Science indicated that found that quite a few of the results, again, the data were available because of the AEA data sharing policy, but that the analyses particularly from from randomized controlled trials were not reproducible. So there was continuing concern on the part of the AEA. The policy that it adopted in 2005 was not sufficient. There was another concern, which was also that a lot of the data that, that researchers were increasingly using in economic analyses were either proprietary or confidential or restricted, and so that a large fraction of authors were saying that they couldn't possibly share their data because of restrictions on making it available to another party. Over this same period, Open ICPSR, which had long been sharing data, began in the around 2012, initiated a series of discussions among editors of social science journals and working with people in federal statistical agencies and federal data policy groups, supported the Office of Science and Technology Policy Memo. And in response to all of this sort of activity and discussions that ICPSR was engaged in with different stakeholders in the social science field, Open ICPSR created what we call Open ICPSR, which really is a repository for data extracts that are used in research articles. And we have since established relationships with other associations, including the Economic History Association and the American Education Research Association, both of which really wanted people to, again, make their data available for reproducibility, for training purposes, in order to provide transparency to the research that was going on. And then, I guess last year or the year before, the AEA, sort of as beefing up its policy, decided that it also wanted to make its data available and the code available through Open ICPSR, so in a more with better preservation and better findability, but also really as a result of the leadership of Lars Huber, the AEA's new data editor, decided that it was actually going to undertake efforts to attempt to reproduce analyses prior to their research. And so that collaboration between two organizations which have been working on this for a couple decades really what culminated in this project. And now I'm going to turn it over to Lars to tell you more about the things that he's been doing, and then Jared and Chelsea can tell you about ICPSR's role. Thank you.
Thank you, Maggie.
And thanks to MIDAS for the challenge. It's a great effort to bring attention to reproducibility, and it's particularly in data science where it's so important.
Yeah. Thank you, Maggie, and thank you, Jacob, for having us go through what we have here. So Maggie laid out the history of this, and in early 2017, I was appointed, early 2018, I was appointed to the data editor position, essentially with the idea, hey, we're not exactly certain what we're going to do, but make it better. And so my vision for this was, let's first make it a lot better, and then make the position of a data editor who has to enforce it become at some point in time obsolete. One can entertain fantasies, whether that will, I'll achieve that goal in my lifetime because people just incorporate reproducible practices in what they do is an open question, but one can hope. I'm going to spend most of this on how we actually do this, but Maggie pointed out this goes beyond simply dumping materials onto journal websites or ICPSR, which is no guarantee for actual computational reproducibility, as Jacob helpfully defined early on in this process. It is only the idea that you can deposit materials there and then not rely on authors' goodwill to find those bugs. And Jake had examples of why we care about those bugs. And the data cleaning, every social science article has some element of data cleaning, even after the data providers have done that, etc. There's a lot of things going on there. In some preliminary work that we did several years ago, we were looking at the posted materials as they were on the journal's website. And most often, the other point that Jake pointed out earlier about most social scientists are poor programmers. I usually choose a much meatier term for that. Our notion from that was, fundamentally, there doesn't seem to be a very big problem, but we're very far away from push button reproducibility because there's lots of bugs, lots of small things that are missed because This is just a tail end process that happens somewhere along the line. So incomplete materials, non-functional code, missing dependencies, all those kinds of things are issues that we found. So we set out to not only move to ICPSR as a way to make more transparent and better curated the materials that we collect, but in doing so, before we put them out there as the version of record, we're also going to try and scale up massively our attempts to reproduce prior to publication of the article the materials that go along with it. And that's what I'm going to talk about here. Jared, next slide. So the required outcomes that we're looking for here are, first of all, and this is where ICPSR plays a really good role, archival record of the scholar's materials, including versioning of those materials. So suppose that we didn't catch a particular error or something like that. There needs to be a mechanism for post-publication updates to that to correct the record, yet maintain the transparency of what was there when it was published and what was corrected afterwards. So the versioning that's implicit in properly curated materials is critical to this. This was not something that normally happens on journal websites when you dump a zip file out there, etc. We also wanted a permanent identifier for these attributes in compliance with all the data citation principles and all that stuff. These are part of the scholarly record and they need a permanent identifier. Now, one could have done that at the journal, but that would have meant putting in place an infrastructure in addition to everything that was going on in terms of the manuscripts. It comes automatically with something like a trusted repository. We wanted linkages to and from the article. Jake highlighted the fact that most researchers don't get credit for either creating data or code, but we wanted to at least initiate that conversation to be able to measure what are the materials that are associated with it. The other part was that we do, while our primary repository is at OpenICPSR, we do entertain deposits at other trusted repositories because we'd actually like this to happen much earlier in the research cycle. Ideally, you've got a proper repository before you go to any journal, and then I don't want you to come back and plunk the stuff that you already have archived on Dataverse or Zenodo or somewhere else, or even somewhere on OpenICPSR and make another copy of it. I don't want that. I want to reference that other copy. So linkages both ways and putting those into the metadata infrastructure at Crossref and DataCite was important to me. We wanted something that would allow us to also inspect the materials before downloading. You want to be able to do partial downloads because maybe you don't want to do all the data prep. The analysis files are there. You just want to run the 5-hour job that runs the analysis files, not the 3-week job that prepares all the data files that requires a ton of other stuff. So we wanted that kind of transparency. And we wanted a proper identification of roles of who's doing what in this process, the author, the distributor, the publisher. And we're starting to see some of that where we get back non-trivial questions about who's the author of the data deposit who might not be the same as the authors of the actual article. 99.9% it's the same, but we have found some cases where people said, yep, I didn't participate in data stuff. That's Joe and Blake, and they're going to be the authors, and I'm not on that list. Jared, next slide. So some of the desired attributes, which is a work in progress, are issues that affect how scalable this becomes from a journal perspective. Journal workflow integration is definitely a work in progress. We're making huge strides on that, but that's typical for the overall industry of journal publications and data curation at this point. There really is, if you want to be open, such as we are to other repositories, there really is no easy solution right now to integrate this smoothly into journal workflows. We need pre-publication access for replicators. I do think that you get much better compliance if you don't throw all the bugs out into the open, so that we can download some of the materials beforehand and not. That's one of the key features of working with ICPSR on this that we appreciated, because that doesn't come automatically when you're using other repositories simply as here's already an archive out there. Now we need to correct it because we found a problem, etc. Role-based access and partial automation are all still works in progress, and there are a lot of repeated tasks. I'll show you the system that we've cobbled together to some extent to make all these things stick. There's a lot of scope for automating some stuff, including automated checks of the reproducibility. In theory, you have a master script, you have a computer program that identifies that single master script that runs from A to Z through the entire analysis, and you can compare the output of that in a machine readable form, you could do a lot of these checks in an automated fashion. We are nowhere close to that, because even when we have a master script that runs through things, the output is not necessarily well identified or machine readable, or is there any common standard to do this? So humans are still a very important feature of this reproducibility aspect. Okay, Jared? So from a user perspective, they don't care about a lot of the plumbing in the background. They're already going to be somewhat confused by the fact that they're going to submit their materials to Manuscript Central, which is what the AEA uses, plunk in any other manuscript management system into this, and they're going to now be asked to deposit their materials at Open ICPSR in a branded data repository that Jared and Chelsea will describe afterwards. And at the end, they will want to see their article published on the AE website. This is where you can download the PDFs and stuff like that. And there's a link that points then to the Open ICPSR repository where their materials end up being. So there's not yet an integrated view onto this that might be ideal, but at least there's two versions of that. And you need to be able to get back and forth between those two versions. That's where those linkages are critical. Jared? On the back end, I need to tie those things together, because at the journal level, I'm going to be tasked out with, hey, here's some materials, please verify whether they're good. Then there's this whole data editor process, and I send back to the editor something that says, yep, this is fine, or no, this needs a bit of work. There's a couple of revisions that need to be done. At the AA, we do this. We introduced a conditional accept mode that we didn't use to have. Other journals have this, so that we now get access to the materials prior to a formal final acceptance. But in doing so, we're also slowing down the publication process, because copy editing and layouting and all that kind of things only happen when something is definitively accepted. And so we need to insert ourselves into that process in the most efficient way. Jared? So blowing out what that data editor process means is that we're technically using Jira here as one of the task management systems. You can plunk in anything else you want here. Our internal processes themselves need to be reproducible, because we're going to get revisions, and we need to figure out, again, when we get revisions, what has changed, what do we need to do. The RA has moved on in the meantime. Somebody else needs to run this. We need reproducibility for scalability here internally. We use Bitbucket for that. We use Open ICPSR as both our final publication mechanism as well as the mechanism by which authors provide us with their materials, but we need to compute somewhere as well. Here's where we leverage the fact that we are at a university, so we have our university computer center that the students need to be trained on. That's called Sizer at Cornell. We have an internal resources, so we do on a regular basis call in outside experts. That might be some graduate student in the department who's an expert on that, but it might also be somebody who has access to the data somewhere in Norway and can run some code for us, etc. And I'll get back to some of those examples. And we need to get to secure data, some other Dataverse and Zenodo aspects, etc. Jira ties it all together. So we're looking at various systems here. Our internal identifier is the Jira identifier. We have a manuscript identifier. We have an Open ICPSR deposit number. And if that happens, and we have a direct link to the deposit if it's not on Open ICPSR, so that the RA who will see this aspect can pull all these things together. He has to read the manuscript, and he has to tie it back to the data. And at some point in time, I need to revise a report and go back to the journal. So this ties it all together. Jared? So what are the tasks that my team here does? There's two relatively distinct set of tasks. The first one is focused on metadata. So the RAs go through and list out all the data sets that an author is using. Now that might seem simple, and in most of the discussion in the reproducibility world, it's like a paper has one data input, it processes it, produces tables, it's a very linear thing, etc. We have economics papers who use 30 different data sets, and they might be well documented, they might not be well listed. There might be one that just happens to show up in some footnote on table 15 or something like that. It's sometimes a really hard process for the RAs to collect all that information because, again, there's no current template on how to do that. we enforce data citations. That's not actually something new, but it's something that for the previous decade had been mostly ignored. And so we ask authors now to provide data citations, and the RAs, once they know what the data sets are that are being used, are going to check, are they also being cited? We check data availability statements. Open access data is you can simply click on it and download, but that's not the norm. Even on some issues, like if you're using an ICPSR data set, you actually have to register. You have to agree to comply with all the rules. You might need to apply to confidential data. That's the data availability statement. And those are not always very clear. Sometimes you access the OECD database and you have to type in some search words, and you can't reference the output of that. You have to describe the process of doing that. That's a data availability statement, and we check that we can actually figure out where the data comes from. And that goes to Jake's point, is that this is about the raw data, and at some point in time, you're going to post-process that, and we also want the code to be complete. That's on the other panel there. And then we check metadata on Open ICPSR. Is our authors there, our keywords there, and stuff like that. And we check the structure. Do we have a proper structure set up? Is there a README file that somebody can read, and all those kinds of things. We then actually download the code and the data to the extent that we can, and in most cases we can actually. We assess code completeness. So do we have everything? Do we have the code that goes from the raw data to the analysis data? Do we have a code that goes from all analysis data to every single figure and table in the paper? Right? Some authors provide us with some neat tables. Other times we have to go through the code and figure that stuff out. At this point, we haven't even run it yet. Only then do we actually run it. So up until assessing the completeness of the code, we need no access to the data. This is done for every single deposit, regardless of how confidential the data might be. And then if we have the data, we run the code and compare the results. The RA then writes a report. I review those reports and approve it, and then it's submitted back into the manuscript central system. That process can take anywhere from 5 hours to 3 weeks, depending on how complex these things might be. And there's a lot of things out there. So metadata, we try and properly populate as much as we can. The key issue is that you tell a social scientist to fill out the metadata, and they will say, what's metadata? And so a lot of these things are going to be, what is it that you actually want? Why do you want it, etc. There are some things we don't discuss. You have to provide them, otherwise you're not going forward. But other things can't be required. Geographic coverage is really important if you're running a survey, and is completely irrelevant if you're running an experiment. And so even some of these elements are not necessarily always going to apply to every single data set, right? And as it turns out, most social scientists don't keep track. What is actually my unit of observation? What is the proper universe for doing these things? And so those are just things where we are lenient about enforcing some of these metadata elements. They should be better documented. That would make for better science, but so far they're suggested because otherwise we'd get hung up here for a very long time. Jared? When I said structure, I mentioned the README, but I also mentioned zip files. We actually want transparency in seeing what the materials are, and up to some technological limits. If you have 15,000 data files in your replication package, we may want to zip a few of those up because that's a bit too much. But we don't want random empty directories, random zip files sitting around that just say, here's my replication stuff, figure it out. So we want those exploded out so you can peruse the system and have it just look at it and say, oh yeah, I recognize that file or that code, I want to have a look at it, and just download that one piece. For reproducibility, for reusability, that's key. Jared? So what do my RAs need in terms of skills? They need non-trivial skills that we actually have to train them on when we get them, because we get mostly, I try to do this mostly with undergraduates in the social sciences, but also computer science, statistics, engineering. We typically get applicants who are in their junior year. Some sophomores are there as well. Sophomores are great because once you train them, they actually like the job. They stay with you for at least 2 years. And we give them a very intensive start session at boot camp, and then it takes 5 to 7 weeks to get them into that mode where they can both understand our systems and understand what they need to do, because this is not taught at that level on average in most universities. At least at our university it's not. So we have to actually teach them this stuff. What do they need to do? They need to read documents and understand where the author is describing what data they're using. If that were standardized, it would be a lot easier. If there were a checklist, it would be a lot easier. That's not how we write articles, right? They need to be able to run code in minimally invasive mode. That means as it comes out of the box, there are some small changes that we all have to make. And we're helped by that most economists write in 2 languages, Stata or MATLAB. Forget about R, Python, etc. Those are small fractions of the overall population. So we can train them on Stata and MATLAB, and we've got 95% of the stuff covered. But that doesn't mean that running Joe's Stata program versus Brandon's Stata program, those are going to be quite different ways of running it. There are so many ways you can do that. So we have to train them on being a bit flexible. This is computational reproducibility. So all we do is that the code runs, it spits out a table, and that is the same table as in the paper. We do not second guess whether those methods are right. They only reliably reproduce the numbers that are there, but you can then inspect the code as a researcher and say, no, they did this wrong. I want to do this again. I want to just change that one thing. And we can guarantee, well, you don't have to debug the whole thing. You can run it as is and just modify your line. So this goes to Jake's point earlier about this is really key to have all of that exposed and reusable. Jared?
Just one thing, Lars. I think we have 5 minutes left in the presentation. Is that right, Jake? Okay.
Okay, so the scale of this is that we have right now about 800 done assessments for 8 journals. Current state is I've got about 20 RAs, but there's a lot of flux. And we do reproducibility checks with confidential data. And then we can talk about the rest, I think, in later on some of the challenges. So I'll hand over to you, Jared, at this point.
Right, Chelsea, do you want to?
Absolutely, yeah. Thank you, Lars. So Jared and I are going to end the presentation today with a quick walkthrough of an AEA project workspace on OpenICPSR and the resulting publish page to provide some visuals for many of the elements that Lars just mentioned. So depositors initiate the deposit of data collection by starting with the Create New Project modal. Next slide, yeah, thank you. And this button is where they enter in a project title and select the AEA repository from the list of repository options. The OpenICPSR identifying number that Lars mentioned is created right away here in this initial step. They then proceed to the project workspace, where the majority of the project work and documentation occurs. And so the next few slides will take us through each of these sections that I've highlighted here one by one. The first section that you saw at the top, that's where users can select to either upload files individually or import from zip. And this slide here shows a glance at what one of those modals looks like. Below that, OpenICPSR offers options for many descriptive metadata fields, some of which, like that for a principal investigator here, they're used to construct the project citation. You'll note from a few of these screenshots that there's a wide variety of metadata field types. So they range from longer free-form entry for fields like the project summary. I think that's on the next slide. Is that right, Jared? There we go. Project summary here, date formats in other cases, and more fixed choice formats for fields like collection mode. We won't go through all of them here, but you can see the range. Those descriptive metadata include some customized fields for the AEA repository specifically, like JEL codes and manuscript number. And taken together, this all increases the discoverability of the AEA projects on OpenICPSR. In addition, depositors and or administrators can add related publications in order to link the data collection back to the published article. And depositors and administrators can also use the project communication log on the next slide, thanks, at the bottom of the workspace for back and forth communication about the data collection to further facilitate the workflow that Lars outlined. Lastly, the project administration tools that we previously saw on the right side of the project workspace can further facilitate various workflows and collaboration by allowing the depositor to share the project, as in this modal here, with any or all of their collaborators. And then the next slide is will show the view log, and this documents all actions that are taken on a project in case there are any questions or confusion. Once the depositor has finished uploading their data collection and editing their project, then it's time to publish. And so once they click on the publish button, the depositor will first see a screen where they can review their project one more time. And then they're routed to this page here, the terms and conditions page, where they are asked to answer some questions about disclosure risk, to select a license, and to agree to the ICPSR terms of deposit. Jared will pick back up then with the published project. Go ahead, Jared.
Thanks, Chelsea. So once the project is published, then what you see here is what's on the main website. Users can access the data. They can view the metadata that was completed by the depositor. There are usage statistics. There's an ability to download the data, and then there's a citation. And by citation, it includes credit for whomever was the principal investigator or the author of the data. It includes the year it was published. And there's a DOI, that's that persistent identifier reference that people can use, and it goes directly back to that project homepage. There's the additional published metadata about the project. They're the versions on the right-hand side, and then the related publications linked to each project. Just a few closing things, sneak peek into new workflows we're building for these journal repositories. This will allow for depositors to submit directly to AEA before it's published. A depositor can recall a submission, resubmit, or create a new version of their project. This then gets submitted to AEA, and they're able to review the deposit and change the status of it. So they can send the deposit back, put notes in about what corrections are needed, and then they can also reject or publish the project. So this new workflow allows the AEA or other journals or professional associations to directly review and submit back and forth the projects before they're published and available on the sites. So we thank MIDAS again for this opportunity, and I know we're at 1 minute past the hour, so I'll turn it back to Jake.
Thanks, Jared. Yeah, we are a little beyond the hour, but I do want to give the opportunity to ask questions if there are any. And again, please type them in the chat window. So while we're waiting for folks to type in the question, I have a question of my own, probably mostly for Lars. So first of all, kudos to the AEA for really taking this on and not just promoting reproducibility as a value, but taking steps to build structure and mechanisms to actually make it happen. My question is, what kind of reception has this gotten or continues to get in the folks who publish in AEA journals? Are you seeing a lot of acceptance or some pushback, particularly given the amount of time that may need to be invested in making all of this happen?
Well, that's hard to answer. First of all, the people I interact with, I'm the last hurdle to go before they get to publish in one of the most prestigious journals in economics, so they don't complain too much. Around the back end, I have gotten the occasional complaints about being too picky and things like that. I have no idea whether that's widespread or whether that's justified. That's not random sampling at all. That's just pointing out that somebody did have bad data publication practices and I corrected them. I also very often, but again, not randomly selected, get appreciation expressed for having helped people make their code and their analysis better. So you get the full spectrum. That's to be expected. We are trying to change people's habits, and people don't necessarily like their habits being changed. So there is a bit of an experiment going on there as well. But in general, I would say there has been no notion at all among the editors that this is a bad idea. We're trying to improve its efficiency. We're trying not to delay papers, and we are creating new delays. And I do get occasional concerns about that. So far, we've always been able to address that. So I think at present, we have not de facto generated delays to publication for any given paper. But we have created perceived delays because we've inserted a new mechanism into that sometimes takes a bit more time. We're working with undergraduates. That is by design. It makes it more affordable to the journal than potentially. I don't know, that remains to be assessed. It's also an educational outreach, but undergraduates do have occasional other things on their minds. Sometimes it's because they have a midterm, and sometimes it's because they get chucked out of their dormitories because of COVID-19 or things like that. Working with an undergraduate workforce is highly variable and causes all manner of gray hair to be added to mine. So
Yeah, as the father of an undergraduate myself, I can certainly understand that.
Yeah.
Are there any other questions before we wrap up? Okay, I'm not seeing anything. Oh, wait. Nope. I'm sorry. I'm not seeing anything come through. So I'd like to thank all our presenters today and to MIDAS for hosting this. As I mentioned, this is a part of a series. The next presentation in this series will take place on June 23rd from 2 to 3 p.m. And that'll be with Oliver Hay, who's an associate professor of microbiology and immunology at the University of Michigan, and Jie Song, a graduate student research assistant at ICPSR at the University of Michigan. And they'll present their work entitled C2 Metadata, Continuous Capture of Metadata for Statistical Data. So thank you all very much, and that'll do it for us.
Thank you for having us.
Yep. Take care, everyone.
Thank you.
Thanks very much.
Thank you.
Thank you.